A key is a device that is used to operate a lock. A typical key is a small piece of metal consisting of two parts, the blade, which slides into the keyway of the lock and distinguishes between different keys, and the bow, which is left protruding so that torque can be applied by the user. A key is usually intended to operate one specific lock or a small number of locks that are keyed alike, so each lock requires a unique key. The key serves as a security token for access to the locked area. Only persons having the correct key can open the lock and gain access. Keys provide an inexpensive, though imperfect, method of access control for access to physical properties like buildings, vehicles and cupboards or cabinets. As such, keys are an essential feature of modern living, and are common around the globe. It is common for people to carry the set of keys they need for their daily activities around with them, often linked by a keyring adorned by trinkets usually known as a keychain. History of locks and keys, ancient keys. The earliest known lock and key device was discovered in the ruins of Nineveh, the capital of ancient Assyria. Locks such as this were later developed into the Egyptian wooden pin lock, which consisted of a bolt, door fixture, and key. When the key was inserted, pins within the fixture were lifted out, drilled holes within the bolt, allowing it to move. When the key was removed, the pins fell partway into the bolt, preventing movement. The warded lock was also present from antiquity and remains the most recognizable lock and key design in the Western world. The first all-metal lock appeared between the years 870 and 900, and are attributed to the English craftsman. It is also said that the key was invented by Theodore of Samos in the 6th century BC. Affluent Romans often kept their valuables in secure boxes within their households, and wore the keys as rings on their fingers. The practice had two benefits: it kept the key handy at all times, while signaling that the wearer was wealthy and important enough to have money and jewelry worth securing. Modern keys. With the onset of the Industrial Revolution in the late 18th century and the concomitant development of precision engineering and component standardization, locks and keys were manufactured with increasing complexity and sophistication. The lever-tumbler lock, which uses a set of levers to prevent the bolt from moving in the lock, was perfected by Robert Barron in 1778. His double-acting lever lock required the lever to be lifted to a certain height by having a slot cut in the lever, so lifting the lever too far was as bad as not lifting the lever far enough. This type of lock is still currently used today. The lever-tumbler lock was greatly improved by Jeremiah Chubb in 1818. A burglary in Portsmouth dockyard prompted the British government to announce a competition to produce a lock that could be opened only with its own key. Chubb developed the Chubb detector lock, which incorporated an integral security feature that could frustrate unauthorized access attempts and would indicate to the lock's owner if it had been interfered with. Chubb was awarded £100 after a trained lockpicker failed to break the lock after 3 months. In 1820, Jeremiah joined his brother Charles in starting their own lock company, Chubb. Chubb made various improvements to his lock. His 1824 improved design didn't require a special regulator key to reset the lock. By 1847 his keys used 6 levers rather than 4, and he later introduced a disc that allowed the key to pass but narrowed the field of view, hiding the levers from anybody attempting to pick the lock. The Chubb brothers also received a patent for the first burglar-resisting safe and began production in 1835. The designs of Barron and Chubb were based on the use of movable levers, but Joseph Brommer, a prolific inventor, innovated an alternative method in 1784. His lock used a cylindrical key with precise notches along the surface. These moved the metal slides that restricted the turning of the bolt into an exact alignment, allowing the lock to open. The lock lay at the cutting edge of the precision machine tooling capabilities of the time and was deemed by its inventor as unbreakable. In the same year Brommer started the Brommer Locks Company at 124 Piccadilly, and displayed the Challenge lock in the window of his shop from 1790, challenging the artist who can make an instrument that will pick or open this lock for the reward of £200. The challenge stood for over 67 years until, at the Great Exhibition of 1851, the American locksmith Alfred Charles Hobbs was able to open the lock and, following some argument about the circumstances under which he had opened it, was awarded the prize. Hobbs' attempt required some 51 hours, spread over 16 days. The earliest patent for a double-acting pin tumbler lock was granted to American physician Abraham O. Stansbury in England in 1805, but the modern version, still in use today, was invented by American Linus Yale, Sr. in 1848. This lock design used pins of varying lengths to prevent the lock from opening without the correct key. In 1861, Linus Yale, Jr. was inspired by the original 1840s pin tumbler lock designed by his father, thus inventing and patenting a smaller flat key with serrated edges as well as pins of varying lengths within the lock itself, the same design of the pin tumbler lock which still remains in use today. The modern Yale lock is essentially a more developed version of the Egyptian lock. Despite some improvement in key design since, the majority of locks today are still variants of the designs invented by Brommer, Chubb and Yale. Types of keys. House keys. A house key is the most common sort of key. There are two main forms. The older form is for lever locks, where a pack of flat levers are raised to different heights by the key whereupon the slots or gates of the levers line up and permit a bolt to move back and forth, opening or closing the lock. The teeth or bittings of the key have flat tops rather than being pointed. Lever lock keys tend to be bigger and less convenient for carrying, although lever locks tend to be more secure. The more recent form of house key is that for a pin tumbler or wafer tumbler lock. When held upright, as if to open a door, a series of grooves on either side of the key limits the type of lock the key can slide into. As the key slides into the lock, the grooves on the blade of the key align with the wards in the keyway allowing or denying entry to the cylinder. Then a series of pointed teeth and notches on the blade called bittings allow pins or wafers to move up and down until they align with the shear line of the inner and outer cylinder, allowing the cylinder or cam to rotate freely inside the lock, which opens the lock. Car key. A car key or an automobile key is a key used to open or to start an automobile, or both. Modern key designs are usually symmetrical, and some use grooves on both sides, rather than a cut edge, to actuate the lock. It has multiple uses for the automobile with which it was sold. A car key can open the doors, as well as start the ignition, open the glove compartment and also open the trunk of the car. Some cars come with an additional key known as a valet key that starts the ignition and opens the driver's side door, but prevents the valet from gaining access to valuables that are located in the trunk or the glove box. Some valet keys, particularly those to high-performance vehicles, go so far as to restrict the engine's power output to prevent joyriding. Recently, features such as coded immobilizers have been implemented in newer vehicles. More sophisticated systems make ignition dependent on electronic devices, rather than the mechanical key switch. Ignition switches or locks are combined with security locking of the steering column or the gear lever. In the latter, the switch is between the seats, preventing damage to the driver's knee in the event of a collision. Keyless entry systems, which use either a door-mounted keypad or a remote control in place of a car key, have become a standard feature on most new cars. Some of them are hands-free. Some high-tech automotive keys are billed as theft deterrents. Mercedes-Benz uses a key that, rather than have a cut metal piece to start the car, uses an encoded infrared beam that communicates with the car's computer. If the codes match, the car can be started. These keys can be expensive to replace if lost and can cost up to $400. A switchblade key is basically the same as any other car key, except in appearance. The switchblade key is designed to fold away inside the fob when it is not being used. Switchblade keys have become very popular recently because of their smart compact look. These type of keys are also commonly referred as flip keys. Because switchblade keys are only developed for new car models, they are usually equipped with a program transponder chip. In the 1950s, early versions of flip keys resembling jackknives were made by the Signarcraft Company out of New York with various period U.S. automakers' prototype dream cars like the Pontiac Stratostreak and the Cadillac El Camino featured on them. These are now popular with collectors. Signarcraft and other manufacturers like Curtis, Taylor Locks, and Mr. Key also produced keys for many 1950s-1970s makes and models known as Crest keys. These were automotive keys that featured an enamel rendition of the auto manufacturer's logo on the bow and were plated in 14K gold. During the early 1960s, these special keys became so popular that oil companies like Mobil, Texaco, and Union 76 began issuing their own logoed versions as promotional items for their customers. Today, these early automotive crest keys are highly sought after by collectors. Meanwhile, companies like Hurd & Briggs and Stratton were making OEM key blanks with automakers' logos on them. These became known as logo blanks. These key blanks were the same as the original keys issued by the automaker and allowed an enthusiast to maintain the stock look of his or her keys. Picky car show judges will often score a vehicle down for not having an correct OEM set of keys with the original lock code stamped on them. Unfortunately, many of these original logo blanks are no longer manufactured and only available from dwindling NOS supplies from internet places such as eBay. Master key. A master key operates a set of several locks. Usually, there is nothing special about the key itself, but rather the locks into which it will fit. These master keyed locks are configured to operate with two, or more, different keys. One specific to each lock and cannot operate any of the others in the set, and the master key, which operates all the locks in the set. Locks that have master keys have a second set of the mechanism used to operate them that is identical to all of the others in the set of locks. For example, master keyed pin tumbler locks often have two shear points at each pin position, one for the change key and one for the master key. A far more secure system has two cylinders in each lock, one for the change key and one for the master key. A common misconception is that master keyed locks are more secure than single keyed locks, but that is not the case. The fact that some pin chambers have two shear points allows for more options when picking, and it also allows for more keys to operate. For example, a standard 6-pin cylinder, which was designed to be operated by only one key, can be operated by up to 2 6=64 keys if there are two shear points in each chamber. Larger organizations, with more complex systems, may have several levels of master keys, where the top-level key works in all of the locks in the system. To visualize this, it can be thought of as a hierarchical chart, or a tree. A practical attack exists to create a working master key for an entire system given only access to a single master keyed lock, its associated change key, a supply of appropriate key blanks, and the ability to cut new keys. This is described in cryptology and physical security, rights amplification in master-keyed mechanical locks. However, for systems with many levels of master keys, it may be necessary to collect information from locks in different subsystems in order to deduce the master key. Locksmiths may also determine cuts for a replacement master key, when given several different key examples from a given system. Control key. A control key is a special key used in removable core locking systems. The control key enables a user, who has very little skill, to remove from the core, with a specific combination, and replace it with a core that has a different combination. In small format interchangeable cores, similar to those developed by Frank Best of the Best Lock Corporation, the key operates a separate shear line that is located above the operating key shear line. In large format removable cores, the key may operate a separate shear line, or the key may work like a master key along the operating shear line and also contact a separate locking pin that holds the core in the cylinder. SFICs are transferable from one brand's housing to another, while LFICs are not. Transponder key. Transponder keys may also be called a Euro or chip keys or Euro. Transponder keys are automotive ignition keys with signal-emitting circuits built inside. When the key is turned in the ignition cylinder, the car's computer transmits a radio signal to the transponder circuit. The circuit has no battery. It is energized by the radio signal itself. The circuit typically has a computer chip that is programmed to respond by sending a coded signal back to the car's computer. If the circuit does not respond or if the code is incorrect, the engine will not start. Many cars immobilize if the wrong key is used by intruders. Chip keys successfully protect cars from theft in two ways: forcing the ignition cylinder won't start the car, and the keys are difficult to duplicate. This is why chip keys are popular in modern cars and help decrease car theft. Many people who have transponder keys, such as those that are part of Ford Motor Company's Security lock system, are not aware of the fact because the circuit is hidden inside the plastic head of the key. On the other hand, General Motors produced what are known as VATS keys during the 1990s, which are often erroneously believed to be transponders but actually use a simple resistor, which is visible in the blade of the key. If the electrical resistance of the resistor is wrong, or the key is a normal key without a resistor, the circuit of the car's electrical system will not allow the engine to get started. Double-sided key. A double-sided key is very similar to a house or car key with the exception that it has two sets of teeth, an upper-level standard set of teeth and a lower, less defined set of teeth beside it. This makes the double-sided key's profile and its corresponding lock look very similar to a standard key while making the attempt to pick the lock more difficult. Four-sided key. A four-sided key has four sides, making it not only harder to duplicate and the lock harder to pick but also more physically durable. Paracentric key. A paracentric key is designed to open a paracentric lock. It is distinguishable by the contorted shape of its blade, which protrudes past the center vertical line of the key barrel. Instead of the wards on the outer face of the lock simply protruding into the shape of the key along the spine, the wards protrude into the shape of the key along the entire width of the key, including along the length of the teeth. Internal cut key. An internal cut key has a rectangular blade with a wavy groove cut up the center of the face of blade, at constant depth. Typically the key has an identical wavy groove on the back of the blade, making it symmetrical so it works no matter which way it is inserted. Also referred to as the inner profile or sidewinder. These keys must be cut by special key cutting machines made for them. Alloy key. Alloy keys are cut from a metal half-cylinder. The cuts are made at different angles, so when the key is turned in the lock it rotates each disc a different amount. Nearly all the houses in Finland use alloy keys, although they are also widely used in various locales worldwide. These locks are considered very secure and almost impossible to pick. Dimple key. A dimple key has a rectangular blade with various cone-shaped dimples drilled into the face of the blade at various depths. Typically the lock has two rows of pins that match up with two rows of dimples. Typically the key has the same dimple pattern on the back of the blade, making it symmetrical so it works no matter which way it is inserted. Kaba and Dom are manufacturers of dimpled keys. These keys are relatively easy to not only pick, but also make impressions of. Skeleton key. A skeleton key is a very simple design of key that usually has a cylindrical shaft and a single, minimal flat, rectangular tooth or bit. Skeleton keys are also usually distinguished by their bow, or the part one would grasp when inserting the key, which can be either very plain or extremely ornate. A skeleton key is designed to circumvent the wards in warded locks. Warded locks and their keys provide minimal security and only a slight deterrent as any key with a shaft and tooth that has the same or smaller dimensions will open the lock. However, warded keys were designed to fit only a matching lock and the skeleton key would often fit many. Many other objects that can fit into the lock may also be able to open it. Due to its limited usefulness, this type of lock fell out of use after more complicated types became easier to manufacture. In modern usage, the term skeleton key is often misapplied to ordinary bit keys and barrel keys, rather than the correct definition, a key, usually with minimal features, which can open all or most of a type of early designed lock. Bit keys and barrel keys can be newly minted or found in antique stores. They were most popular in the late 1800s, although they continued to be used well into the 20th century and can still be found today in use, albeit in vintage homes and antique furniture, and as decorative features of jewelry boxes. A bit key is distinguished from a barrel key in that a bit key usually has a solid shank, whereas a barrel-shafted key can be made either by drilling out the shank from the bit end or by folding metal into a barrel shape when forging the key. Tubular key. A tubular key is one that is designed to open a tubular pin tumbler lock. It has a hollow, cylindrical shaft that is usually much shorter and has a larger diameter than most conventional keys. Antique or vintage-style barrel keys often closely resemble the more traditional skeleton key but are a more recent innovation in key making. In modern keys of this type, a number of grooves of varying length are built into the outer surface at the end of the shaft. These grooves are parallel to the shaft and allow the pins in the lock to slide to the end of the groove. A small tab on the outer surface of the shaft prevents the pins in the lock from pushing the key out and works with the hollow center to guide the key as it is turned. The modern version of this type of key is harder to duplicate as it is less common and requires a different machine from regular keys. These keys are most often seen in home alarm systems, vending machines, laptop locks, and bicycle locks, in the United States. These keys typically come in 7 and 8-pin versions as well as miniature versions used on computers. Tubular keys were invented by the Ace Lock Company in Chicago. Zeiss key. A Zeiss key is a cross between a house key and a tubular key. It has 3 sets of teeth at 90 degrees to each other with a flattened fourth side. Though this type of key is easy to duplicate, the extra sets of teeth deter lock-picking attempts. Do not duplicate key. A do not duplicate key is one that has been stamped do not duplicate, duplication prohibited, or similar by a locksmith or manufacturer as a passive deterrent to discourage a retail key cutting service from duplicating a key without authorization or without contacting the locksmith or manufacturer who originally cut the key. More importantly, this is a key control system for the owner of the key, such as a maintenance person or security guard, to identify keys that should not be freely distributed or used without authorization. Though it is intended to prevent unauthorized key duplication, copying D&D keys remains a common security problem. There is no direct legal sanction in the U.S. for someone who copies a key that is stamped do not duplicate, but there are patent restrictions on some key designs. The Associated Locksmiths of America, ALOA, calls D&D keys not effective security, and deceptive because it provides a false sense of security. United States Code 18 U.S.C. Sec. 1704 deals with United States Post Office keys, and 18 U.S.C. Sec. 1386 deals with United States Department of Defense keys. Restricted key. A restricted key blank has a keyway for which a manufacturer has set up a restricted level of sales and distribution. Restricted keys are often protected by patent, which prohibits other manufacturers from making unauthorized productions of the key blank. In many cases, customers must provide proof of ID before a locksmith will cut additional keys using restricted blanks. Some companies, such as Medeco high-security locks, have keyways that are restricted to having keys cut in the factory only. This is done to ensure the highest amount of security. These days, many restricted keys have special inlaid features, such as magnets, different types of metal, or even small computer chips to prevent duplication. Magnetic key. A magnetic key lock is a locking mechanism whereby the key utilizes magnets as part of the locking and unlocking mechanism. A magnetic key would use from one to many small magnets oriented so that the north/south poles would equate to a combination to push or pull the lock's internal tumblers, thus releasing the lock. This is a totally passive system requiring no electricity or electronics to activate or deactivate the mechanism. Using several magnets at differing polarities/orientations and different strengths can allow thousands of different combinations per key. Keylay card. A keylay card is a flat, rectangular plastic card with identical dimensions to that of a credit card or driver's license that stores a physical or digital signature that the door mechanism accepts before disengaging the lock. There are several popular types of keylay cards in use, including the mechanical hole card, barcode, magnetic stripe, wig and wire embedded cards, smart card, and RFID proximity cards. Keylay cards are frequently used in hotels as an alternative to mechanical keys. Key duplication. Key cutting is the primary method of key duplication. A flat key is fitted into a vise in a machine, with a blank attached to a parallel vise, and the original key is moved along a guide, while the blank is moved against a wheel, which cuts it. After cutting, the new key is deburred, scrubbed with a metal brush to remove burrs, small pieces of metal remaining on the key, which, were they not removed, would be dangerously sharp and, further, foul locks. Different key cutting machines are more or less automated, using different milling or grinding equipment, and follow the design of early 20th century key duplicators. Key duplication is available in many retail hardware stores and as a service of the specialized locksmith, though the correct key blank may not be available. More recently, online services for duplicating keys have become available. Certain keys are designed to be difficult to copy, for key control, such as MeDeco, while others are simply stamped "Do not duplicate" to advise that key control is requested, but in the US, this disclaimer has no legal weight. Rather than using a pattern grinder to remove metal, keys may also be duplicated with a punch machine. The key to be duplicated is measured for the depth of each notch with a gauge and then placed into a device with a numeric slider. The slider is adjusted to match the corresponding measured depth and a lever is depressed, which cuts the entire notch at once. As the lever is raised, the key automatically advances to the next indexed position and the slider is adjusted appropriately to the next measured depth. This cycle is continued until the key is complete. Duplicating keys by this process is more labor-intense and requires somewhat better trained personnel. However, keys made in this fashion have clean margins and the depth of the notches are not subject to wear-induced changes encountered when heavily worn keys are duplicated using a pattern grinder. Keys may also be made in this fashion without an original as long as the depth of each notch and the type of key blank are known. This is particularly useful for institutions with a great number of locks for which they do not want to maintain a wide variety of archived copies. A machine permitting rapid duplication of flat metal keys, which contributed to the proliferation of their use during the 20th century, may have been first invented in the United States in 1917. The key to be duplicated is placed in one vise and the blank key to be cut in a corresponding vise under the cutting disc. The vise carriage is then into such position by means of a lateral feed clutch that the shoulders of both the pattern and blank keys just touch the guide disc and cutter respectively. The lateral feed clutch on the top of the machine is then thrown, and the vertical feed rod released into action and power applied through the combination hand crank power wheel on the right of the machine, until the cutter has passed over the entire length of the blank. A duplicate of the pattern key is obtained in about 1 minute. In recent years, dual-key cutting machines have come onto the market, enabling cutting of both mortise and cylinder keys on one machine. These machines are primarily manufactured in the Far East and save a key cutter a significant amount of money compared with using two separate dedicated machines. Heraldry. Keys appear in various symbols and coats of arms, the best known being that of the Holy Syria derived from the phrase in Matthew 16:19 which promises St. Peter, in Roman Catholic tradition the first pope, the keys of heaven. But this is by no means the only case. Many examples are given on commons. See also, key, passphrase, password, personal identification number, personal unblocking code, references. External links, LockWiki, How Master Key Systems Work, a highly experienced locksmith/engineer discusses the functionality and benefits of master key systems, those tough-to-pick door locks, September 1969. Very good article. Illustrations on modern 20th century door locks, why you should consider changing your locks regularly. A trusted locksmith explains why you should change your locks regularly.